Now we have a basic computer organization. So earlier we have seen digital computers, their peripheral devices. Now basically we are going to see what are the requirements are there for the computer to perform the operations. So let's start in that continuation of that first topic is the instruction codes. And we have previous lectures about digital computer. If still you didn't see, you can see in the playlist. We have separate playlist for the computer organization. And if you didn't subscribe, please subscribe it and share with your friends. Let's start with instruction codes. So name is the instruction. How we are going to give the instruction to the computers. In general, how we are going to give the instruction to the processor so that processor will perform the operation. So those combination of the binary numbers, combination of the binary bits is called as the instruction codes. So different processor will have different instruction codes. They have different formats. They have different size. Okay. So here we are going to discuss that may be applicable to the particular basic computer alone. But basic structure remains same, only size is going to differ. So different processor will have different registers, buses, micro operations, and machine instructions. So the different types of the registers, buses, and micro operation already we have seen in under the digital computers. Okay, and the modern processors, you know that is going to perform with very high speed, so it has complex system, and mainly these processors consist of many registers and we have multiple arithmetic units. Also we call as ALU, arithmetic logic units, for the both integers and floating point calculations. And it has ability to perform the various operations simultaneously in the pipeline ways. Sometimes it can perform the parallel processes. Sometimes it can perform the pipelining, means if one will be executed, then next task will be executed. Now, first see what is the basic computers, how it is being organized. So this basic computers having two main components. One is the processor, another is the memory. So here for the particular system, we are going to consider that memory has capacity of 4096 words. So these words will be located, each word will be stored in unique location. So this memory will have 4096 location also. So this 4096 can be written as to the power 12. So with the help of 12 bits combination, we can generate the 4096 address. So that each and every address will have a unique word in their location. Now suppose this word size is 16 bits long, then memory capacity will be to the power 12 cross 16. So this to the power 12 shows that number of words can be stored, and this 16 shows that what will be the size of the words. So each word having 16 bits. So here you are seeing that this is central processing unit and it is on for the RAM. So RAM having a total location, we have 4096 locations are there. Okay, so generally it will start the counting with 0 and finally it will go up to 4095. So last is what? 4095. And each word having capacity of 16 bits. Next, we have instructions. How these instructions are going to play the role here. So instruction is what, just like a program. Our program is what? It is a sequence of the instruction. So that instruction must be understandable by the machine. So for the machine instruction, how we are going to organize those things, it has group of bits that's going to tell the computer that which type of the operation is going to be performed, or it is going to tell about the sequence of the micro operation, whether it is arithmetic micro operation, whether it is logic micro operation, or it is going to be the shift micro operation that we have seen earlier. So this instruction of program along with whatever data is required, so that data either it is available in the memory or it is available with the data registers. And this CPU, that is the central processing unit, is going to read the instruction from the memory. So this instruction is available where? It is available in the memory. So from the particular address, this instruction will be taken. After that, generally you will see that letter will have three main steps. One is the fetching, second is decoding, third will be the execution. So first instruction is being obtained. So after getting the instruction from the memory, it will be placed in the instruction register. Later we are going to see the size of the instruction registers. So it will be size of the 16 bits. So this instruction is taken from the memory and finally it is stored where? In the instruction register. Now this control circuit having task to understand this instruction register contents. So it is going to translate that instruction into sequence of the micro operation that is necessary to be implemented. So here we have this task, what is being performed here, it is also called as the macro operation, not macro operation. Since this control issues the sequence of the micro operation for each operation code. Later we are going to see what is the operation code. Okay. Next we have a stored program organization. This all discussion is under the instruction codes. If they're asking about question is about explain, discuss about instruction codes, all these things you need to discuss. You have to explain. Now this computer instruction having two parts. One part having opcode, another part having address. So this opcode is going to say that which type of the micro operation is going to be performed, and address is going to give the location of the particular in the memory, or is going to specify the particular registers. So in general, we have seen that in basic computers, we have to the power 12 number of the words in different location, and this 12 bits of the address is required to complete all 4096 addresses. Okay. So here you see that this 15, so total 16 bits are there. Out of these 16 bits, later we'll have structures that we are going to see. So in that instruction code, this 0 to this 11, so total 12 bits, it is going to talk about the address. Next we have from here 12th bit to 14th bit. Okay, that is going to give the information about the opcode. And last 15th bit is going to tell about which type of the address we are going to use, which type of the addressing modes we are going to use. So 0 to 12 for the particular computers, these 12 bits are for the address bits. Then remaining 12, 13, 14, these 3 bits are for the opcode bits. So total with the help of 3 bits, total will get the 8 combination. So here 8 different types of the micro operation is possible here. And I is going to tell which type of the addressing modes. If it is 0, then it is going to show the direct addressing mode. If it is 1, it is going to show the indirect addressing mode. So that also we'll discuss. So here this memory words having 16 bits long. Okay, and these 4 bits are left for the instruction and instruction part of code. So that out of these 4 bits, one is for the addressing modes and 12 bits are here for the address. In some operation operand is required, memory means you are going to obtain the information from the memory, and in the sum operation is not required to get the data or information from the memory. Like we have clear, complement, increment of the contents of the accumulators. For that, memory communication is not required. Read or write operation with memory is not required. Okay. So now you have again here basically if you see that instruction format here, so it has 16 bits. 0 to 11, that is the 12 bits are given for the address for the particular computers. Here to the power 12 is 4096. So that's why we are talking about 4096 address. So these 12 bits are here for the address bits. Then 12 to 15, these 4 bits are for the opcode bits. So out of 4, basically 3 will be only responsible for which type of the operation will be performed, and last will be for the 15th bit will be for the which type of the addressing mode we have. So finally here, total binary operand we have 0 to 15, that is your 16 bits here. And it shows that we have instruction and operand. Operand is what? Data. Okay. So this 16 word size is what? 16. So that's why here we have 16 bits for the operand. This is the data which is stored in the memory, or which is going to be stored in the memory. So finally, this memory size for this computer is 4096, means to the power 12. These are the address, total location in the memory, and 16 shows that word size. So each word having length of 16 bits. And below part we have processor registers. So this consists of accumulators where we have multiple registers to perform the various tasks. Next we have addressing modes. So these all things are under the instruction codes. Maybe separate question also can be there for the addressing modes. So address, that is the how we are going to reach to the contents in the memory. For that we have either direct address or indirect address. So direct address means here in the instruction code, particular address will be given. By that address, directly will reach to the operand. That example here, if you see here, we have, this is the instruction code of the 16 bit, and by the opcode here addition operation should be performed, and this 0 shows the direct addressing mode, and this 457 shows the address of the operand. So once we'll reach this 457 address, so here whatever information is there, that is our operand, that is our data. So finally this addition operation is being performed here between the contents of the accumulators and which data is available at the address of 457. Between these two, addition micro operation takes place. Okay, here addition takes place. So this is the example of the direct addressing modes. Whereas in case of indirect addressing modes, it will give that address which is available in the instruction code, that is going to give the address of the operand. Directly address is not there. Like suppose somebody will tell you that if you are going to search something, they will go tell you that you go to particular location. At that location, you'll get the exact location where you want to reach. So that is the address of the operand. That is happening in case of indirect addressing modes. So this is the example of indirect addressing modes. That's why 15th bit is here 1. Okay, this shows the indirect addressing modes, and it is going to operand is addition. So micro operation addition will be performed here. Again, here we have seen that we have 3 bits. With the help of those 3 bits combination, we are going to decide that which type of the micro operation is being performed. Here for the particular combination of the opcode, we have addition operation, and this address is what here? 300. So now you see that by the help of this 300 address location where you are going to reach. So here we have 1350. So this 1350 is not our data. It is not our operand. So by it is the address of the actual operand. So from here, again, we are going to address of the 1350. At the address 1350, that having the contents, that is our operand, that is the data. Now here, finally, we have reached the operand. Okay, so finally addition operation will be performed between the contents of the accumulators and the operand what we have obtained here. So addition will take place. Again, this information is stored again in the accumulators. Another thing, something we call effective address. Okay, so effective address What is the effective address? That can be directly used without modification to access an operand for a computation type instruction. So here that address directly you are going to reach to the operand or as the target address for branch type instruction. Later we'll see that when subroutine will be performed. So where how this effective address is going to play the role. So for the branch type instruction, we are going to use the concept of effective address apart from the direct address and the indirect address. So these are diagrams are very, very important. After that, you can explain. Okay, in computer organization, diagram is very, very important. So these are the things how instruction codes are going to work here. Okay. So if they'll ask you the question about the instruction code, so you have to explain about a structure of the instructions. Then you have to explain about this addressing modes. Okay, how this operation is going to perform. So these are things about the instruction code. Thank you. Thank you very much.